Hello, my name is Caleb Cummings, and today I'll be talking about materials management as a tool for the construction and engineering industries. What is materials management? Is it making sure that you have enough materials? Is it making sure you have the materials available when you need them? Or is it simply minimizing the waste on a project? How do we define materials management? Safa, Shahi, Haas, and Heipel describe materials management in their article in Automation and Construction as the planning and controlling of all activities necessary for ensuring and confirming that the correct and accurate quantity and quality of materials and equipment are appropriately specified in a timely manner, obtained at a reasonable cost, and are available when needed. So, what all does this entail? It means sourcing suppliers that can provide not only a product that meets the quality specified by the architect or designer, and also meets the budget and has the ability to be provided in line with scheduling needs. It also means that getting the appropriate amount of these materials in order to maintain budget while still allowing for errors, damage, or any other unforeseen circumstance throughout the procurement and delivery process in order to not delay the progression of a project. Last, it is also means to make sure that materials ordered are used in the most efficient manner to minimize waste and human error. Why do we need to use materials management? The primary reason is that the cost of materials can amount somewhere between 50 and 60% of the overall project budget. And management, procuring, and obtaining these materials or equipment can account for nearly 80% of the project schedule. When you look at a typical project management system, it is primarily focused on the execution and implementation of the project, while those aspects may only make up less than half of all costs associated with the project. On complex projects, the percentage of the budget that materials make up can reach nearly 70%. This can be seen on heavy industrial plants such as refineries and even on cruise ships and offshore oil rigs in the construction of those items. In fact, the sectors of the oil and gas industry and the shipbuilding industries have given this information and the technologies to the engineering construction industries because these areas of the industry have such a high material to budget ratio. And when the material to budget ratios are extremely high and not managed properly, budgets can tend to get blown out of proportion and schedules can get significantly delayed. Projects are becoming more complex and specialized, and within these projects, the materials and methods that are used become more specialized or complex to meet not only the needs of the project, but to also meet the vision of the designer or architect. But the specialization of materials and methods can limit the availability of certain materials and equipment. For example, at the University of Oklahoma, in the early 2000s, they were constructing a parking garage adjacent to the existing football stadium. Due to the size of the structural members and the required location of the crane, a specialized heavy lift crane had to be procured in order to make these heavy lifts. There was only one crane west of the Mississippi that was available for the duration and at the time that the project needed it. These materials that it was to be lifted, the structural members of the parking garage, had to be ordered and delivered within a specific time in order to not delay the crane at all because of the high cost per hour that the crane was and its very, very tight schedule. These beams needed to be delivered just in time to make sure that they could be put in place and not delay the projects very, very significantly, to the tune of several months. In addition to projects becoming more complex, schedules are becoming more compressed as owners want their buildings faster, and generally whenever they need them more rapidly, it's because there's a lot more money at stake, especially whenever you look at high revenue producing projects such as gas processing facilities, refineries, and other structures that can potentially create large value for the owner. This means that many activities need to be occurring simultaneously on the project, and that makes more items critical to the process and puts them on the critical path, which allows more chances for delay on a project, because a simple delay in the critical path, perhaps due to materials being late or equipment not being available, can significantly affect the project timeline. Simultaneously, more items, especially long lead time items, are on the critical path, and many of the suppliers of these items are keeping less in stock and less in inventory to reduce their inventory overhead. Oftentimes they will only produce items on demand, which can increase the lead time for some items due to setup and production times tremendously. It isn't uncommon to have specialty items be out 6 to 8 weeks, if not 3 to 4 months in a lot of cases, depending on where you have to procure your items from. For example, some specialty marbles and stones from Europe may take 6 weeks simply in transit. That's not including the time to quarry and produce those items, which can range upwards of 6 to 8 weeks depending on your quantity. Planning is vital to the success of any construction project, but it is especially key within any materials management system. Often materials planning includes vendor evaluation and the selection, which may or may not be with a detailed analysis through an integrated construction material management model, which I will discuss in further detail later. Material takeoffs of prefabricated, modular, bulk, and built-in-place items. Purchasing and transportation of materials to the site. The transportation must take into consideration things like oversized loads, hazardous materials, removal of waste materials, and other items potentially a pre-standing structure or existing conditions and minimizing the disruption to the public from inconveniences, whether it be deliveries or equipment moving or road closures due to an extremely oversized item. Throughout this process, it is extremely important to be in contact with subcontractors. This is because subcontractors supply a majority of bulk materials and small equipment. For example, electricians are going to supply all of your wires and all of your light bulbs and those types of items, your conduits and all that. It would be unnecessary, and most of the time the subcontractors are going to be unwilling to allow the project manager or the prime contractor to purchase this material, because that is a way that they make some of their money, is through the profit and overhead on those materials. But in turn, the contractor, the owner, typically supplies the specialty, larger budgetary items. Another example would be hospitals. They typically provide and purchase the large ticket specialty items such as MRI machines, CAT scan machines, but all the while contractors must coordinate between the owners on delivery and the subcontractors about preparations needed for these specialty items to be put in place. There are several tools that can be used in materials planning. The first is a bill of materials that is typically used for composite elements that are made up of various items and may have multiple trades associated with them. These bills of materials are to make an easier way for subcontractors and suppliers to be able to price out these materials without having to analyze the entire assembly. The second are quantity takeoffs and material coding systems. These two items are typically used in conjunction, and for an effective material management strategy should be used in conjunction, and can be used to track various materials during the project, as well as provide a reference at the end of the project to see what errors may have been made in the procurement of the materials for the site, or to see how effective a waste management strategy was. Last is the use of an integrated construction materials management model. This model is typically used for the purchasing and procurement of materials, as I mentioned earlier. It can also be used for the evaluation of suppliers for selection, analysis of supplier and subcontractor proposals, and can be used to deliver purchases, inspecting goods supplied, and maintaining records. It is often that the bill of materials and quantity takeoffs and material coding systems are a part of this integrated construction materials management model, and are in essence a simplified ICMM model, each on their own. When using material management strategies on projects, the ICMM model can play an important role in the success of a project, and with having a more detailed model can further increase the success of the project. Material scheduling is another important aspect of any project. Materials need to be scheduled so that way they arrive in time, not to delay the project, not too early that it crowds the project due to limited storage, or that there's a chance that damage may happen to the product. As mentioned earlier, delays in material arrivals may impact a schedule by significant amounts. Typically, a delay on arrival could cause a delay of the project by more than simply the days that the material was late. Crews may have to be rescheduled, or equipment may have other priorities, and typically the delay could grow. Many projects have begun to use radio frequency to track materials progression through production, transportation, and installation, which is giving contractors more reliable data to estimate durations for procurement. And the last item, one of the most important material issues across the industry is project waste. Waste affects everything from lead credits to cost and scheduling. It is a truly universal project issue. All projects have some form of waste prevention strategy in place. These strategies include well-organized purchasing, proficient ordering of materials, effective delivery schedule, meaning that you don't waste valuable equipment time, whether waiting on a truck to arrive to unload or having not enough evenly spaced deliveries to warrant certain equipment to offload materials. Effectual storage, which is to prevent damage or deterioration of products. Maximization of reuse and prevention of rework, which is the largest cause of waste on projects, whether due to human error or design changes in mid-course. In conclusion, each company typically has their own form of a materials management system. Some may be more elaborate than others, but everybody tends to have some form of materials management. It is key to evaluate what works the most effectively for each company, because each company is different, and provides the greatest amount of success without being an excessive process, meaning that it should not be a process that does not add value. It should always add value and be effective while adding value. Once it becomes too cost ineffective, it's when it needs to be reevaluated and appropriately scaled. Utilizing supplier evaluation techniques, scheduling and coordination aids, and waste prevention techniques can reduce cost overruns and schedule delays, which further contribute to material management. Thank you.